what is 5G? It's not only a continuation of 4G, because now the focus is 100% data. So voice is actually just another data application among all the other ones. So it's not voice-centric at all. Also, we have switched out the entire logic. We, I say, the industry has switched out the entire logic. So 5G standalone, and I'll explain what standalone is in a minute, is a lot smarter, really, than 4G technology. And 6G, and I like to be clear on this point, 6G doesn't actually exist. It's on the table for lots of standardization discussions, and these discussions tend to take years because there's so many stakeholders. The International Telecommunications Union are the ones who order these standards, but 3GPP, the organization, are the ones who actually create the standards. But from the point when 3GPP releases a standard, you can download it from the net. There's a lead time. First of all, the vendors like Ericsson and Nokia need to implement their technology as products, and then they need to be tested and integrated into the operator environment. And telecom operators tend to have very complex both IT and operational stacks. So it takes a long time, basically. It could take up to like 5-6 years from standard release to actually standard being able to be used. So the lead times are long, and that's one of the reasons why we launched Northstar, actually. And as you can see, 3GPP divides the releases of standards into various blocks. Northstar is currently on release 17 and being prepared to move to release 18 as soon as possible. And as you see, the standards were finalized a few years ago, but they are still not around in the market, and that is due to the lead time I mentioned before. So let's keep that in mind. It takes time to go from the standard to actual users having it in their hands. And many operators, I would say, in the world are running on this release 15. I mean, it's not a bad release, but it's old. And oh, sorry, I'd like to mention that 3GPP is an amazing organization because there are 830 stakeholders and they all need to agree on these standards. I still think it's black magic that it even happens, considering how the world looks like. So it's, in a way, a success story, I would say, so far. And Northstar, then, is 5G SA core, which uses the latest 3GPP release as soon as Ericsson have tested and validated, well, first of all, developed, but then tested and validate the technology. So it's not experimental stuff. We get stuff that is actually properly tested. And so the main, I think, takeaways from 5G compared to 4G is you all know about the increased speed, mainly downlink, but also uplink. We come back to the uplink aspect later. The reduced latency is extremely vital for many application areas. So having shorter response times, basically. Being able to guarantee quality in various ways through network slicing and quality parameters. And finally, the level of security has been upped one level. It wasn't bad in 4G, but it's even better in 5G. So what is Northstar? I mean, that's really the main topic of this presentation. It's a strategic collaboration between Telia and Ericsson. Börje Ekholm and Alison Kirkby, who was CEO of Telia back then, they shook hands 2022 and made an agreement to connect the industry, academia, and the public sector through making this environment available This is all part of sort of accelerating development around cellular technology in Sweden. Not only the technology as such, but the use cases that make use of the technology. So Northstar is a 5G standalone dual core innovation network. It runs in parallel to the public radio network, the network that you all hopefully use, unless you use another operator. What this means is that the radio is the same. We can use any radio base station in Sweden, as long as it belongs to Telia, of course. We can also use private radio if a company happens to apply for their own spectrum from PTS, which is possible. We have done that for some of our partners. So we are, in a way, radio agnostic. And dual core, that basically is the backward compatibility. It means that we actually have all the 4G technology as well. If you want to run 4G traffic, that's perfectly fine. There are some technologies like narrowband IoT, which is 4G specific, so we support that as well. Okay, but what is 5G standalone? It is a new brain in the mobile network where all the logic is contained and processed, and that is what we call the 5G core. And that is completely disconnected from LTE 4G technology. The 5G that is available publicly today is called non-standalone. And what does that mean? It means actually that all the logic is handled by the old 4G core, the 4G brain. So we don't have access to all the advanced capabilities of 5G today. We have the speed, but that's basically all. So 5G non-standalone is what has been launched by basically all operators in Europe. I would say there are a few who has launched standalone, like you can count them on the fingers of one hand. So we want to make 5G standalone available to all the enterprises, organizations, public sector, whatever, who needs to test 5G standalone now, because we all know that this will be on the market within 2 to 4 years. And then we need to be prepared, like a company, a vehicle manufacturer who has connectivity built into their vehicles. They don't want to build on today's technology, which will be obsolete in a few years. They want to build with tomorrow's technology. So we can provide them a test environment for securing that their vehicles actually work tomorrow. And that's important also on a global scale. 5G standalone will be available globally. So you need to be able to test it here in Sweden. And as I mentioned, we can connect to any base station. We actually have one at the LTU campus. I don't know, you're in the cellar so you can't see it, but it's by Kårhuset, I think. And basically we can connect any base station to Northstar if necessary. And we can also build new ones if needed, where there is no coverage. Yeah, I think that is sort of the main geist of Northstar. Any questions on this? Northstar, the main driver is our partners. Of course, there's a lot of tech push in this industry. I mean, I can't deny that. But we are very much driven by what our partners tell us, what their needs are. And as you can see, we've been working with many different sectors. The transportation sector has been very eager to explore Northstar. Healthcare is growing. Forestry is another area. And I would say that the first big industry to push Northstar requirements was the mining industry, beginning with Boliden, but we also have other mining partners, but mainly Boliden. Boliden have been very, very active in this area, and I know LTU has a cooperation with Boliden as well. So it all ties together, and we really love it when partners work with partners. That's when the magic happens. All right, but this is really what it all boils down to. This is Northstar in a nutshell. The architecture on a relatively simplified level. And as you can see, there are 3 levels here. First of all, we have the core, which is the brain, the logic, where all the signaling is processed, and the capacity, the latency, the quality for each connection is decided, configured, controlled, and decided. And skip this one, come back to it. Then we have the radio network, and as I said, we have 99.9% coverage in Sweden, so that's a very powerful radio network that we can make use of. But this in between, which is quite often overlooked, but extremely important. I mean, the radio base stations, they don't exist without connectivity, fiber connectivity. So we have an immensely large transport network underground in Sweden, all across Sweden. No one talks about it, but it's really one of the main strengths of the network. If you don't have it, well, basically you don't have any connectivity. But it's there, so that's good. And then we have radio, and as I mentioned, we can use the public radio, the existing ones that you see when you look out the window if you're not in a cellar. And then, as we discussed, if you're applying for spectrum yourself from PTS, we support that as well. And then there's something strange here in between. Not so strange, but it's called breakout. Breakout basically means that we take the user plane, which is called UPF in 5G. And the user plane basically is where the data is handled. So all the signaling is handled by the core. But here, the breakout, where the data is processed, that we can break out from the core. And the core sits in Stockholm in one of the most secure facilities in Sweden. I can't even tell you where it is, but it's far from Luleå, not surprisingly. But the good thing is that we can take this user plane breakout and install it at the partner location in your own data hall. And that decreases the latency quite a lot if we're talking about the distance between Luleå and Stockholm. If it's Stockholm and Uppsala, I mean, then it really doesn't matter. Latency is not improved that much. But for the length of Sweden, this is quite important. Another very important advantage of these breakout nodes is that you keep your data locally. Your data, which might be sensitive, doesn't travel to Telia Central Data Center. It stays with you, and that's important to many partners. I have also written regional here. We do have a project with RISE, mainly driven out of Luleå as well, where we have built 3 regional breakout sites. And what that means is that we're using Telia data centers that already exist in Luleå, in Skellefteå, and in Uppsala. And there we connect directly to RISE and their edge cloud compute platform called ICE, I believe. In the future, that could be other cloud edge compute solutions like AWS or Google or Microsoft or what have you. It doesn't really matter. Yeah, and in the end, of course, we have all different use cases. We'll come into that later. But the interesting thing then about 5G is that you can tie all these layers together. Oh, now I revealed what's beneath the surface here in the core. Just here's it straight. There are like 30 plus different modules. The 5G core is a very complex system, and that's just what I wanted to illustrate. So we have all these 30 servers in this secure data center. We operate it, we host it, Telia hosts it, but Ericsson manages it because they have the expertise. This is requires very specialized expertise, so they manage it for us. But anyway, my point was that the things here to the left, the vertical bars, they illustrate what is called network slices. And network slices are basically virtual networks within the network. and they can be defined in the core to cover the entire chain of connectivity all the way down to radio. And what it can do, what the slice can do, is to set what quality level is available, what speed uplink downlink is available, and what latency, what response times are available, and also priority. So this is quite powerful because it means you can tailor these virtual networks within the network to different use cases. I've written down some examples here, like video conferencing, automotive use, drone control. So this is completely new to 5G standalone, and one of the deal breakers, I would say. I think this is a very powerful technology, network slicing. Finally, before I leave this slide, there are 3 additional components here. The top one here is the API, and the API is also new for 5G standalone. And as a standard, it's called Network Exposure Function, NEF, and that's not really something for ordinary application developers to use because it's very sort of telco centric. So what we have done is we have taken that API and we put another layer on top of it based on a standard called CAMARA, which comes from GSMA, the Association of Mobile Operators. And CAMARA is simple to use for ordinary application developers. And what you can do with CAMARA, I think I have separate slides on that, but for instance, you can control the quality on the fly. You can switch between different quality levels, and you can also position devices. But there are, like, I think 30 plus APIs from CAMARA, and we have started to build 2 of these, and we have implemented these APIs in our API environment called Telia API Gateway, where we can onboard all our partners. We actually have onboarded LTU. I think it's mainly LTU Robotics who have started to use it, and a couple of other partners. So this is pretty straightforward to use, actually. It doesn't take long to get up and running. And finally, we have Ericsson Network Locator, and that is the platform which processes all the data needed to position a device, a piece of equipment, a person, whatever, using the radio network and the core. I'll come back to that later as well. And finally, a bit separate, I would say, Ericsson Security Manager. It's a security hardening system, which is especially useful for customers who have extremely sensitive operations, like think emergency services, defense, and so on. For instance, this system can automatically detect a false base station, and false base stations are more common than you would believe. They are often mounted in vans that drive around and pretend to be Telia base stations and then connect to our network and can sniff data. So that is prevented by this module. Okay, so there are very many capability areas within 5G SA and also within Northstar then. I mentioned network slicing. I don't think I need to go into that in more detail right now. I also mentioned network exposure, which is the API capability. I'll have some examples of that later. Positioning, I also mentioned. Positioning includes both outdoor and indoor positioning, which makes use of 2 quite different technologies. Outdoor, in 5G SA, we have started to use something called timing advance. So that's the time it takes for the signal to travel between the device and the cell. And then we have also angle of arrival. So that means measuring what angle did the signal arrive from. And those parameters together, especially if you have enough cells around you, can give very good precision. So we're talking GPS level precision, basically. And this is something which is pretty new and untried. And we're doing testing on this as we speak together with Ericsson. And then we have indoor positioning, and that makes use of radio dots, and you have those at LTUs. You know what they look like. They are almost like these fire warning dots. And we have two projects actually, because in Mjölkullsberget, sub-T, we have also installed radio dots to be used for positioning. And then we have a hospital in Stockholm, which has actually hundreds of these radio dots. And here you can get down to 1 to 2 meters of precision, which is quite powerful. The caveat here is that you need to do radio planning very carefully, because indoor environments are, of course, very different than outdoor environments. You have doors, you have walls, you have stuff in the way. Ericsson has a tool called Ericsson Indoor Planner, and that now also helps not only to give you maximum coverage, but also maximum positioning quality. So this is an area where I think we are a bit of pioneers, and it looks pretty promising, I would say. This hospital wants to mainly locate the equipment of some reason gets lost in hospitals. Hospitals are huge, and stuff just travels around and no one knows where these items are. So they are really looking forward to being able to position equipment. Edge nodes I already talked about. Those are the ones that we call breakout nodes. And then security manager I also discussed, that can detect false base stations. So these are 5 examples. There are many, many more, but I think these are perhaps one of the most important ones. Now I would like to talk about quality, because one of the main advantages of network slicing is the ability to control the quality levels. And quality levels in 5G are called 5QIs. And there are, I don't know, like 100 different 5QIs or so. And we have tested one particular 5QI called 79, and it's particularly tailored for V2X, so vehicle-to-vehicle communication. And in this test that we did together with AstaZero, which is one of the most advanced digitalized automotive test tracks in the world, this test was actually done with using the CAMARA API, the TLA API gateway I talked about. So this parameter 5QI79, it was switched on in the second case here, but in the first case it was not switched on. So what happened between these two demos was that the API switched on the quality parameter. So let's look at the first film here. And what we should be looking at is that there's a car approaching far here in the background. It will pass behind the truck here. And there will be another car coming, and the view will be obstructed. So the car coming from this direction won't see the other car. And it's an autonomous vehicle. So it will brake, but it can't brake until it has detected the other vehicle. And then it looks like this. So what happened here was that the autonomous car didn't see the approaching vehicle until it was too late, until it had passed the truck. And when it was braking, it didn't have the latency required. So there was a delay before it actually stopped the car. And then the API switched on the low latency quality parameter 79, which then gives the communication a much shorter response time. And that makes a difference because the signal to brake comes a lot quicker. Well, that was the one. Let's see if we can get the right one. Here comes the second one. So due to the low latency of the 5QI79 quality parameter, the car got a signal in time to brake and there was no accident. So that's a pretty good example of what you can do with quality parameters and network slicing. Later.
Yep.
Okay, I think I'm approaching the end here. Oh no, not many pictures. I take this one first because it relates to positioning that I talked about. The first picture here shows a test of outdoor positioning in Kista. The blue line is the real movement of a vehicle, or maybe it was a bicycle or something, I don't know. The yellow line is what the 5G SA system detected. It's not too bad, but it's of course a very limited test, but it's promising, I would say. One of the first tests of this kind. And if we look at indoor positioning then, in the middle here is just a sort of floor plan of the hospital. One of the floors in the hospital, they have like 20 buildings and 100 floors or something like that. So for one particular floor, we did this measurement, which is shown to the far right. The red dots show the actual location of the device in question, which was positioned. And the blue-green dots are the ones measured by the 5G positioning system based on the 5G dots. As you can see, they are not too far off, except this one here down to the left. And that can have to do with reflections, or perhaps even if it's close to a door, that there's an outdoor cell which creates interference. So there's lots to think about when it comes to radio planning for positioning. But yeah, these are good results, I would say. And we hope to do the same thing in Mjölkensberget, but that activity has started later, so we haven't come that far. Yeah, and now a summary of sort of recent deliverables, and I will be repeating myself a bit, but I didn't mention the fact that we have connected 150 kilometers of highways to Northstar, and that is of course to provide our automotive partners for the possibility to test, for instance, different quality levels, network slices along public roads, if Trafikverket allows it. I mean, if you want to drive an autonomous vehicle on a public road, that's very difficult to get permission for. But yeah, we have prepared this infrastructure. Unfortunately, there's nothing in Norrbotten or Västerbotten. There might come later in other projects, EU finance projects. But right now, these are mostly in the south of Sweden.
I read about some autonomous bus that will go in traffic in Gothenburg.
That's Jenny's specialty.
Is that connected to Northstar?
No, actually, that's something that I guess that's a typical example of when you do a project in the society and you don't think, I mean, connectivity comes next. First, you start with the project. So for the moment, we don't know how they have solved the connectivity part, but
But they have permissions to go autonomous, but with a driver behind the wheel, or
yes. But the difference with this project compared to other self-driving bus projects is that this is a full-size
bus,
autonomous bus.
Yeah.
It's a Turkish bus. Yeah, but we are invited to a meeting with them after they have had the premiere.
Okay.
So,
but have you discussed then having highway corridors then for that autonomy?
No.
No.
Not yet. They have not opened up for dialogue.
Okay.
Yeah.
Who is leading that?
It's Trafik and the
Yes.
city of Gothenburg.
Okay.
Yeah, but they are curious about the connectivity questions, but they want to start the project first.
Yeah.
So I guess that's.
But it is interesting that it's finally happening in Sweden, more or less.
Yeah.
We have
that's
vehicles on the public streets, more or less.
They have done it in Norway, Stavanger somewhere. So they have already. It's the bus operator V that are driving this project, and now they have got permission to do it in Gothenburg.
And Salem also I remember it's coming there as well.
Yeah, I think so. Into that project, but I'm very curious about the Gothenburg project. Me and Anders was on the call before, but we have. I mean, it's just next to Telia office where we are located. So the bus will go outside our office. So we're super knowing more about this part, the connectivity part, of course.
Yeah.
Yeah, the whole transport industry is a bit split, I would say, between how to do autonomy and remote control. Should you use cellular connectivity, or should you just rely on all the sensors on the vehicle itself, or a mix? It's really not settled yet, I would say.
And maybe another comment on that is that I don't know if you're familiar with Gothenburg, but just next to where the bus will be driving is a huge arena, Ullevi, where there are huge concerts. And there is also the amusement park Liseberg, where the bus will pass. And there is also this Svenska Mässan, Swedish big fair. So there are so many people in this area using, of course, their mobile phones. So that's why we're very curious about the connectivity part. Yeah, if they have thought about
Will it work?
Yeah.
It will be
But
challenged.
let's see.
Yeah, we shall see. Edge breakouts, I already talked about the 3 breakout centers we have in Luleå, Skellefteå, and Uppsala, and we hopefully this project called Digital Arena Sweden, which Vinnova has announced and that we are working to apply for, and if we get that grant, we probably will expand the number of breakout installations by 10. I mean, so spread them all over Sweden, hopefully.
Question regarding the breakout in Skellefteå, is it running in Skellefteå?
So we had a colleague, Mats Axelsson, who was running this project. He left just a couple of weeks ago, and I'm taking over that project, but I haven't gotten a proper handover yet. So my answer is maybe.
Okay. Because I am from the Skellefteå campus, so when I was trying to connect to that, I believe that communication was to this breakout, not to the.
Yeah, exactly. That might be I recognize that. So I need to get my head wrapped around the current situation and drive that project forward. I'll start having meetings with the RISE team this week.
But Ivan, when you know more, can we maybe come back to you?
Yeah, sure, completely, yes.
Yeah, who was asking the question?
So, yeah.
Safis, but you can go through Björn and me,
Yes.
Ivan.
Yes.
Annika
Okay.
here.
Okay.
We have a similar question relating to the outdoor base station in Skellefteå as well, because affecting the indoor traffic in Skellefteå just as it has been in Luleå. So we are really keen to get an update on them connecting to the North Star core as well.
Right. So let's touch base on that. As I said, I have just been recently taking over that project, so I need to get a better understanding of the status.
Yeah, you are welcome in Skellefteå.
Yeah. Oh yeah, I've been in Skellefteå many times. It's a great place. So I'll be glad to come there.
We will have more. I mean, Ivan, you are stepping into that project, but there will also be 2 more colleagues working more in that project. Very soon. So we will speed up.
Yes, there will be a new recruit actually, and hopefully that person will take an even greater responsibility since I have a lot of stuff on my table.
Yes.
But yeah, Skellefteå is not forgotten. Positioning, I talked about, don't need to repeat that. Auto positioning, I also talked about. Then we have RedCap. RedCap stands for Reduced Capability. And that is the first completely 5G standalone IoT technology, because all the other technologies like LTE Cat-M and narrowband IoT, those are 4G technologies. They depend on 4G core and radio technology. But RedCap runs purely on 5G technology. And what's good about RedCap? Well, it gives you actually, I would say, 4G speeds, but with very much reduced battery consumption. And what are the use cases for that? I don't know, but I could imagine, like for instance, surveillance cameras, video, especially. So not, you know, these very short narrowband IoT messages. This is overkill for that because this has a lot more capacity. So it's really a new niche between the full power of 5G and sort of the limited power of 4G.
Will it be in wearables, for instance?
I'm sure there will be, and there are rumors. I guess I shouldn't say this, but there are rumors about a company which is sort of associated with fruits, that they are working on it. So I believe RedCap will happen, but it's often the case that someone needs to lead. So I would like to see a commercial actor, a big commercial actor, do something, because that will make everything else happen within the operator community. Next item is not really a feature as such. It's a general requirement that we have heard for many years, and which I think actually was a bit overlooked, to be honest, when 5G standardization started many years ago. The uplink capacity in 5G is something many people are asking for. Can we get better uplink? Because there are, if you look at traditionally why data and how data transfer was supported in cellular networks, it was all about downloading, watching videos and stuff like that. But now we're talking about, for instance, remotely controlled cars, where you need the video feed being sent uplink and with good quality. And that requires a number of different tuning and tweaking. There is stuff that can be done on the radio network, and actually we have implemented quite a few technologies already in the radio network, which improves the data upload speeds. But I should mention that there is a hard limiting factor, and that is the so-called frame rate that the regulator, so in Sweden it's PTS, sets. And that frame rate basically tells you how you are allowed to use the spectrum. And I believe the rules right now are you have to use 80% for download and only 20% for upload, something like that. And that's hard to get around. It's like the law. So we're fighting a bit against the law here. Then we have an interesting technology called L4S, low latency loss scalable, low latency, low loss, right? And interestingly, this was more or less invented in Luleå by Ericsson R&D, Ingemar Johansson. And fact is, one of the very first tests in the world was done in LTU campus on the old innovation network that preceded Northstar, and the results of that test were very good. There are videos of that I guess Annika could dig up somewhere. But this was very, very early stages. It wasn't a complete standard. Now it is, and now we will be implementing it, according to all the specifications. And we hope to be able to deploy this. There are 3 partners in Northstar who have asked for this, so LTU is one of them. And we'll make sure to get this up and running as soon as possible. And L4S, just to explain, maybe there's someone in the audience who can explain it even better than me, but it's basically about maintaining the connectivity even if the capacity degrades. So you have a continuous video signal. The quality of the video signal might vary. You might get a bit lower resolution, but you always have the control. You have the video without interruptions. There are no, hacks and black screens and stuff like that. So it's a very, very useful technology, I would say. And finally, completely new on our table, on our roadmap. It was introduced by Ericsson to us before the summer, and the standard is called Joint Sensing and Communication, JSAC. Ericsson has their own name called ISAC. They like to have their own names, but it's the same thing. What it basically is to use the 5G network as a sensing network, and you should think of this as a 5G radar, so being able to detect objects and even stuff like, is it raining or not? Endless possibilities with that technology, I would say. And of course, again, the defense sector is very interested in this, but there are many civilian applications as well. Very good. I'm approaching the end. I guess you are getting tired of me. How much time do I left?
You can continue. I mean, it's we have plenty of time, so.
I have three slides left, so let's walk them through. This is related to the API gateway. I perhaps covered that a bit briefly, so let me explain it in a more pedagogical way. So the 5G core contains a component called network exposure function. All the cores in the world, 5G cores, will have this function. It's a standard, 3GPP standard. But then it's nothing, as I said, to expose to application developers because it's so telco centric. So what we have done and what many other operators have done is they have northbound implemented an API gateway with REST-based interfaces, which are very easy to use for ordinary application developers. And the standard we use to expose these APIs towards application developers is then, as I mentioned, CAMARA. And there's even an entire company now called Aduna, which Ericsson has co-founded with many of the largest operators in Europe, like Telefonica, Orange, Deutsche Telekom, and TIM, and whatever. And they are all using CAMARA. So the idea is that you shouldn't implement different applications with different APIs for different operators. You should write once, deploy everywhere using CAMARA. And we are fully aligned with that standard. That is what we use. It's the CAMARA standard. And as I mentioned, it has been onboarded for LTU and Astacero and yet another customer that I won't mention. And this is just a bit boasting, I guess. We have now a new partner in Northstar, which is the Swedish Defense, namely FOI, their R&D department. So we're building a network for them. Of course, I can't tell you any details since I'm under NDA for that. But I can tell you that the armed forces are extremely interested in 5G capabilities, and they are doing a lot of stuff in this area. And all of this, as I understand it, is very much also coordinated within NATO. So there will be stuff being done in other countries, and that needs to fit together what is being done in Sweden. So this is a new partnership for us, and it's I think it's fair to say that 5G or cellular technology in general is also pretty new to the Swedish defense. So here is an excellent opportunity of exchanging information, innovation, creation of new capabilities that makes Sweden and the other Nordic countries a more powerful player, both in defense and communication. Okay, this is my final slide. And Northstar developer community, you could actually say Northstar community because not everyone are developers, but everyone has their own interests, their own businesses, their own use cases. The APIs makes it possible for them to use the network in an easier way, but more interestingly, perhaps is the fact that we share knowledge among the partners. It's a very open ecosystem in that sense. We share everything we can, which is not under NDA. And that we do in monthly meetings, where all our partners are invited. Telia, of course, we are hosting them. Ericsson often comes and present something completely new they have developed, like JSAC or ISAC. So you learn something every meeting, I would say. Even I learn something. And then a couple of times a year, we have physical meetings, face-to-face meetings, and those are quite interesting. We haven't had too many, but the ones we have had have been very successful. I don't know, Jenny, if you would like to fill in on that.
Yes, so we're planning for the next physical meeting on the 8th of October. This time we will be in Gothenburg. Next time, maybe here in the spring. So we're planning for a full day of both updates from the activities around Northstar, but also sharing between the partners. So everybody gets 50 minutes to share what projects and activities they have, and then inspire each other, hopefully, and maybe find new collaborations. So that's also an opportunity, maybe.
Very good. That was the end of my a bit long-winded presentation, but I think I covered a lot of ground, basically presenting the entire scope of Northstar. We have a roadmap. I won't show it to you because it would take like 2 hours to go through. But safe to say, we're always looking ahead towards the next capabilities that we can implement in the network. That's our task, to always be ahead of the public network. So we will continue that.
Thank you, Ivan.
Thank you.